Hello everybody and welcome to my session, Building Geo-distributed APIs with Azure Functions. My name is Anton Boyko. I'm a Microsoft Regional Director and Microsoft Azure MVP. What is worth mentioning is that I don't work for Microsoft. Those are the titles, basically the awards, and Microsoft recognizes me for my contributions into the community. You can also see my email here, so if you will have any questions about this session in particular, feel free to drop me an email and I will try to answer those. So, saying that, let's basically jump to the topic. And if we're talking about geo-distributed APIs, then you may actually ask yourself, so why do I need those geo-distributed APIs in the first place? So what is the purpose behind that? And I can always talk about recovery from disaster, for example, about high availability and about how it actually brings more performance into your app. But today, I want to make it a bit different. Today, I want to tell you the story. And as every good story, it starts with once upon a time. So what was actually happening once upon a time? Once upon a time, I was doing my groceries. And you may ask yourself, so we are in the middle of the IT conference and why this guy is talking about his groceries? So the idea here is that as a manufacturer, you're actually limited by the physical dimensions, basically, of your packages. And the idea here that, for example, I have a pasta and I want to buy it, but I don't know how to cook it. So probably as a manufacturer, again, as a seller, you want to explain me basically that I need to do this and that. And also you may want to explain me that, this pasta actually tastes better if you also buy one of these sauces or something like that. So how you can actually do that if you are limited by that physical dimension and that physical size of the package? Let me try to explain and show you how it was implemented with this particular brand. So I will grab my phone here and I will grab one of those packages. What I will do now, I will open basically my camera, I will open the QR code scanner, and as you can see here right near the barcode, I have a QR code. And if I will scan it, I will be automatically redirected basically to the website when I can get all the information about this product. So this is actually the big idea behind this one. So as a manufacturer, I may, for example, produce those items, basically those products somewhere here in Ukraine, but then I may ship them worldwide. And what I want to have basically a single entry point which will be globally distributed, and I want to identify each and every product by unique SKU number. And then, for example, when someone in the other country, in, I don't know, UK, Poland, Norway, US, Brazil, whatever, will basically scan the same QR code, I want to get the IP address of that person, and what I also want to do there, I want to basically, based on that IP address, determine to which country it belongs to, and then redirect this user to the local website with the local recipes and some information about this product which is relevant to this user and to this region. And during this session, I will basically show you how we implemented that in one of the projects I was working on and what we learned during the implementation. Before we proceed further, let me highlight a few important points here. So first of all, this is definitely not an advertisement of this particular Ukrainian brand. Second, all the details that I will share with you today about the implementation, they are not based on this particular brand as well. To be honest, I don't even know how the guys actually implemented that in the first place. Recently, I was working on one of the projects basically related to the similar company of the similar nature who works globally, literally in each and every country worldwide. And we were basically implementing the same approach for their products. I was using this local Ukrainian brand, first of all, because I'm really proud that here in Ukraine we have our own companies that are basically utilizing the same approach, and they are also willing to enrich the end user experience. And second, unfortunately, I'm under NDA, so I cannot share the name of that original company I was working for. Let's talk in a bit more details about the actual business needs that drive our implementation. The first need, or like the first goal, was about enriching the end user experience by actually breaking those physical boundaries. So what was really crucial for us here? First of all, we need to identify each and every unique SKU by unique QR code. This is more or less straightforward thing actually. The second one is more about the constraint, that as a part of my manufacturing process, I need to encode and print that QR code on my physical package. The next thing was about that because I need to print my QR code as a part of the manufacturing process, I need to be able to actually have full control over all the redirects that will happen in the future. Because the business rules in the future may change, and that is why I don't want to, let's say, recall all the products and then reprint all the packages, all the labels again to comply with the new business rules. So I need to have the full control over the redirects there. Another important thing, another important goal that we were also pursuing was about getting actually more insights from the fields, let's say from the buyers. So the idea here is that now, because we have full control over redirects, it means that we can also track those redirects. It means that we can actually track all the scans that are happening. And if we know that, for example, in that country, like 1 million scans actually happened, but only, I don't know, like 10 items were purchased, it means that we are doing something really, really wrong. And we need to change that. And as a manufacturer, basically, I want to know about that rather sooner than later. Let me show you the flow, basically, how it works in real life. So let's see that we produce that item here on our factory in Ukraine. We have our SKU, we have our QR code. What we did next, we basically shipped that through like 3 different locations. And then the potential buyers basically start scanning those items. The first person who scanned it was the person from UK, and we understand that by his local IP address, so we redirected him to the UK version of this website, to his local version of this website. The second person basically who scanned it was from Ukraine, and again we understand that by his IP address. So what we were able to do, we were able to redirect him to the Ukrainian version of the website, to the landing page of this particular product. The next person who scanned it was from Sweden. And the issue here that, let's say, we don't have a dedicated website for Sweden. So what we can do in this case? In this case, we can say that we have a default rule, and the default rule says that if in Sweden we don't have a local website, then let's say redirect this guy to the UK version, because there is much bigger chance that that person will be able to speak English rather than Ukrainian. But let's say that we have another example. Let's say that we have like 3 countries, Ukraine, Belarus, and Russia. And let's say that we don't have enough capacity to basically handle 3 different websites for those 3 different countries. In that case, the business rule may look like the following. So it may be that for example, all those users will use the Russian version of the website as a default website. But again, for example, for other users from Europe, because they may not know Russian, we will redirect them to English or other language versions. So in that way, we can kind of group those countries by language similarities. And while we were implementing that, we of course faced some interesting challenges. And what will happen next? Of course, I will share with you those challenges, and also I will share with you the learnings that we were able to obtain while we were solving that. Let's talk about Traffic Manager first. So here I am on Azure portal, and as you can see, I've already created a Traffic Manager profile. There are no endpoints yet, and I want to show to you basically how you can configure it using the different routing methods. So let's start with the configuration. If I will go here, my current routing method sets to priority. So if I will go to endpoints, if I'm about to create an endpoint, it will ask me the regular questions like the type of the endpoint, the name and stuff like that, but there will be one mandatory parameter called priority. The idea here is, let's say if I have a few endpoints with priorities like 1, 2, and 3, then the Traffic Manager will always use the endpoint with the priority 1 first. And only if that endpoint is unavailable, it will then switch to the endpoint with priority 2 and stuff like that. So why you may want to use that? Let's say that you may have like two environments. The first one you use for production and the second one you use as a disaster recovery environment. In that case, you may want to say that the production environment has the priority 1 and the disaster recovery environment has the priority 2. In that case, only when production will go down, the traffic will be switched to the disaster recovery environment, but still the endpoint will be the same. Okay, so we're done with this one. Let's go to configuration and let's change the routing method to performance. I will save it. Okay, so now if I will go to endpoints, let me close this one here, and if I will add an endpoint, as you can see, it will basically ask me the type, the name, and that's basically it. So when we are talking about the performance profile, how it will actually understand to which exact endpoint you need to be redirected. In that case, it will basically measure the latency. And performance profile means that you will be always redirected to endpoint where you will have potentially lower latency. So basically the endpoint that is closer to you. Okay, that was it. Now let's go and check how it works with the geographic profile. I will save it again. Okay, and now if I will go to my endpoints, and if I will add a new endpoint, again, type, name, but here, as you can see, I have a geo mapping. So what I can do here, I can say, okay, so let's choose my first region. That will be, for example, Europe, country, let's say Ukraine. And I can also choose the state if needed. Let's add one more country here. That will be Europe, and that will be, I don't know, let's say Belarus, for example. Why not? So here what I have basically my endpoint, and I define that for this endpoint, if the traffic basically will head it from either Ukraine or Belarus, it needs to be redirected to that particular address. I can create a second endpoint for other countries, for example, like as I was showing in my slides for UK, Sweden, and so on and so forth. And in this way, you can kind of implement what we were talking about, that from different countries basically will be redirected to different IP addresses. But the only one issue here is that in this case, it's super complicated then to manage it. So you may still use it in some of the scenarios, but for that scenario that I described at the beginning of my presentation, I'm not sure that this is really kind of a feasible scenario. Again, because all the extra complications that will came to manage those. Let's check what we have for the Azure front door now. And again, here I am on the portal. I already have my front door created and I also configured it. So let's check basically how it looks like. I will go to the front door designer, and here, as you can see, I have 3 buckets: my front ends or domains, my backend pools, and also my routing rules. So in the context of this session, all the magic actually happens within the backend pools. So let's check this one. The backend pool called func, and as you can see, I have 2 backend host names. So let's say kind of 2 servers, 2 endpoints that I will balance my traffic between. So this is the Azure function, the same Azure function deployed and in North and West Europe. And the idea here is basically front door will use a bit different algorithm to decide to which exact node he needs to send the traffic. So first of all, the front door will check the priority. And in our case, priority 1 and priority 1 here means that both nodes has the same priority. So they are equal. Next, it will check the performance. So the way how it will check the performance of those is shown here. So under the load balancing section, I have a few attributes, and one of those called latency sensitivity. So let me say that I will put 300 milliseconds here. What it will mean? The front door will continuously send the health probes. And because front door is a globally distributed service, so it's deployed basically on all the nodes across Azure, it will send those probes also from all the nodes across Azure. And for each and every health probe, it will measure the latency. And here, in my case, if I will say that my latency sensitivity is 300 milliseconds, it will basically mean that if the health probe was able to respond in under 300 milliseconds, then we consider this as a good performance. If it takes more, then okay, we still recognize that backend as a healthy backend, but we will not send any traffic from this edge node to this backend server because we didn't pass the latency sensitivity threshold. Again, if both of those West Europe and North Europe are under 300 milliseconds, then again they are equal in terms of performance. So the next parameter, as a tiebreaker, it will use the weight parameter. In this case, I have 50 here and 50 here, which will basically means that it will distribute that traffic equally in a, let's say, round-robin way between North Europe and West Europe. I can say, for example, 10 to 50. It will then means that for each 10 requests it will send to North European region, it will send 50 requests to the West European region. So as you can see, in terms of the front door, it's a bit more complicated, but still you're more flexible in terms of how to configure your load balancer. The second challenge I want to talk about was ensuring the global presence. To be honest, that was not really kind of a big challenge for us, because if we will check this map, we will see that Azure has a lot of data centers worldwide, so we can easily deploy our application to all of them simultaneously, and we can easily create that single entry point, as I was showing you before. But what is really important to understand here when we are working with ensuring the global presence was the next challenge: how you can still maintain the reasonable total cost of ownership for that kind of a scenario. So let me show you this graph here. Let's say that you are working with the classical approach of hosting your applications on top of VMs or probably web apps or containers, whatever. You will still need to reserve at least minimal amount of resources, like for example at least one CPU and at least some pre-reserved amount of RAM. You can always scale on demand, of course, but you will still need to pay for this extra over provision. And if you want to basically cover the global audience and want to deploy your app in all the data centers worldwide, then you will basically need to create at least this one machine with like one CPU and 1 gig of RAM in each and every data center, and you will need to pay for it as well. In case of the Azure Functions, you can deploy everywhere, but then because the billing model works in a way that they will charge you for each and every invocation of that function, and also for the amount of compute resources that were consumed for that invocation, then you can easily deploy it worldwide, but then you will still pay only for those resources which you're actually using for your application to run. So this is really kind of a cool approach. Of course, it will force you to create your application in a bit different way. So what I want to do next, I want to basically show you how you can create those Azure functions that potentially will cover all the requirements that we were talking about during this session. It's finally time to check the source code of my Azure functions. So let's do that. As you can see here, I'm in a Visual Studio Code and I prepare basically a few functions just to use them as an examples of what you can do and what you need to be aware of where you will create your own functions. So my first function here called health, what is important to realize is that, as you can see, it looks more or less as a regular web API controller with a few modifications. So first of all, I have my method run, which is marked with function name. And also I'm using the HTTP trigger. And here I have the HTTP request object, which will basically has all the parameters of my HTTP request. The difference between Azure Functions, which uses HTTP triggers, and the regular web APIs is that web API actually gives you a full control on HTTP context, routing, modules, and stuff like that. With the Azure Functions, all the Azure Functions basically work based on event-driven approach. So each and every time an event will occur, the function will be triggered. And those events, they can be different. In my case here, the event is a new HTTP request. The other examples of the events may be, for example, a new message in a queue, or a scheduler, basically a timer, or something like that. So here, as I was saying, in this request object, you actually have all the properties of your HTTP request. But if you will try to access, for example, HTTP context.current, that will be equal to null. So you don't have basically that framework of web API here yet, because the concept is different. But anyway, let's check actually what I also configured here. So first of all, I said that my authorization level is equal to anonymous, and this function will react on a get method. This is a pretty simple and straightforward kind of a health check-in function. As you can see, I have nothing actually here. I'm just returning the OK object result with the healthy word to the caller. Of course, if you want to use this one as a health check endpoint, you may want to, I don't know, go and check that you have connection to the database and that connection is valid and database is still there and stuff like that. So probably this function should be renamed from health to keep alive. But anyway, this is the good example that you can use. You can ping this function, and if it will reply with HTTP 200 OK, it means that at least Azure Function Runtime was able to start and was able to run and execute your function. The next function I want to show you called headers. So this is very useful for the, let's say, debugging and the understanding of how you can work with that HTTP request in a context of our business needs. But what I want to show you here is that this is the same more or less signature. I have a function name attribute, I have my HTTP request here, and what I'm doing, I'm basically creating a string builder, and then I'm iterating through the headers in my HTTP request. I order them by key and basically populate a table with those headers. And then I just return it to the user. So as you can see here, another difference is that I don't have here the support of the Razor template engine, for example. If I want to generate an HTML and if I want to return that HTML to the user, so kind of emulate, like a regular ASP.NET MVC application, that's possible, but I still need to do all those hacks with basically either rendering the HTML in my own way or somehow hack the ASP.NET MVC Razor basically templates here. But anyway, the point is that I was able to create an HTML and I return it back as a content result with the content type text HTML. And you will understand in a moment why I actually need to have those functions. Because here's where all the magic actually happens. But the magic is very simple, of course. So the redirect function, this is the function which actually handles all my redirects. Let's check what I have here. So first of all, the flow works as I described. So as soon as I get the request, I will call my getIP-from-request method to basically get the client, the end user IP address from the request. Then I will call it a third-party service, and again, I'm just using it here as an example. In the real life, if you don't want to be dependent on the third-party service, you can basically acquire a database of all the IP addresses with the correlations to which countries they belong to. But again, for the sake of this demo, I basically use the third-party free API for that. So I have my IP address, I call that API, and I basically try to understand what country this IP address belongs to. Then what I'm doing, I'm checking the location parameter because that API returns kind of a big and complex object to me. I check this location parameter. If the location parameter is present, it means that the IP address was successfully matched to one of the countries, and I will create a redirect result, and that API that I'm using, it will actually send me a URL to this particular country flag, basically to an SVG. So the idea here is that if I was able to match the IP address to the country, I will be redirected to an image with this country flag. If I was unable to do that, I will be redirected to my API headers functions. Let's also check those two other methods below. So getIP-from-request. This is really important part because when you're working in this global setup, because you may have a lot of hops, a lot of other servers between your backend, like Azure Functions, and your client, like basically a person with a mobile phone who scans this QR code somewhere in the mall. You may have all those different, as I was saying, kind of hops, hubs, and basically endpoints. And that may be really hard to understand at some point what was the original IP address of the user. What you can do in Azure, for example, with Azure Front Door, you can say that I want to know what was that actual address, and the Azure Front Door actually, it will include a special header, and this is like a standard, so it's not like only Azure Front Door can do that. It will include a special header called x_forwarded_for, and into that header, he will basically put all the IP addresses in case there were a lot of different hosts on the route from the client to the backend. It will include all those IP addresses, and you will be able to trace it back to the original IP address of the client. So what I'm doing here, I'm basically checking my headers. I'm trying to get x_forwarded_for header, and then because that header can also include, for example, a port number that we were using to make a request, I'm also taking the first header because that's always, that's always the value of the IP address of my end user. I'm splitting it basically by the colon, and then I said I want to have the first part, which is basically the left side, so the IP address only, without the ports. So, and in case everything was successful, I will return this one. In case something failed, I will just return 4 zeros as a basically dummy and not valid IP address in the context of that third party that will try to match it to the exact country. And this is the way basically how I call that third party service and how I actually ask to match the IP address to the country. First of all, I check my environment variables and the variable called ipstack_key. In that environment variable, I basically store my API key. Then I basically create this simple URL, and again, I create a regular HTTP client, and I'm just executing a GET request for that URL. Here I have the key, so everything is super simple. Then I'm trying to deserialize that response. If everything is okay, I will use it. If not, I will just create an empty object and I will return that final object basically back to my Azure function. And here I will grab it and then, as I was explaining, check the location and do the stuff. So let's see actually how it works. I have those Azure functions up and running on my local host, and here I have a postman, so let's start with the health endpoint. I will go here, I will send this request to my local host, I have healthy, and as you can see, the execution time was only 16 milliseconds. That's also very important because if you have this health endpoint or keep alive endpoint, you also want to make it in a way that it will respond as fast as possible. Now let's check the headers. So I will call this function, and this basically the response that I have. Let me just switch to the preview. So this is kind of a more fancy way to check it. So this is my headers. Those are my values. What I can do, if needed, I can switch to headers. I can add, for example, Boyko and MS stage. Execute it again. This is Anton Boyko. This is MS stage. So as you can see, everything again works as expected here. And now let's check the redirect method. So what I have here, I basically have my URL, but we are also assuming that our Azure function is basically sitting behind the front door. What it means that the front door, as I was saying, will add that X forwarded for header. So let me switch again to my headers, and as you can see, let's say that for this request, we were using 1234. So that was the IP address of our user. Send. We can have a country flag here, which is awesome. Let's check what will happen if we will use this IP address, for example. We will have a different country flag. Let's use another IP address. And we have a different country flag again. So this is the way how we were able basically to hook everything up. So we were using the front door as an entry point, we were using Azure Functions, we were able to get the actual IP address of the client, match it using the database, which was also stored locally with the Azure function itself, match it basically to the exact country, and then based on that country and based on our active business rules, we were able to redirect that user somewhere. Our challenge number 4 was about overcoming the cold start issue. So if you worked with Azure Functions before, or maybe any other implementation of function as a service approach, you understand that it works in a way that you will pay only for the actual invocations. That basically means that your app can be deployed worldwide, but if provider of those resources will see that no one is using that app, it will basically shut it down. So of course it will be virtually available for receiving the traffic, but let's say that your app was shut down and then the new request basically came in. So what will happen in that case, for example, in Azure? As you can see here on this diagram, the Azure will need to find basically a server for this function to run on. Then it needs to basically provision a worker on that server. That worker basically needs to provision the runtime, load all the libraries in memory and stuff like that. So a lot of heavy lifting actually happening here, and only at the end you have your custom code. In case your app is warm, then only your custom code will be run there. From my previous experience, I can say that in Azure, basically all that heavy lifting, it can take from maybe 2 to maximum 10 seconds. And in general, it's still awesome because, as I was saying, my app is virtually there, and it takes only 10 seconds basically to provision all the required resources and generate a response. But on the other hand, let's say that in our case, as we were talking about during this session, the user somewhere in a mall scans with his phone this QR code on the package, and then he needs to wait for like 10 seconds, basically, just so we can warm up the resources for this redirect, and after that, when we even redirect him to the end website, then it may take again some time to render and basically send him this HTML page, and then he will need to load some resources like images, CSS files, and stuff like that. So we're talking here probably about like, I don't know, maybe overall 15 seconds of the load time, and I'm not sure that this is actually a really good end user experience here. So if I were a user, I could probably live with that, but still the overall impression about the company, because the website was loading so slow, that will be probably not really good. So the idea here is that we need to find a way how we can basically keep our app warm, but on the other hand, I don't want to pay or like prepay for any reserved resources. So let's check how we were doing that in our project. Let's talk a bit about the economy. So how we can actually still maintain the consumption plan, how we can have our app deployed worldwide, how we can eliminate the cold start, and how we can still maintain the reasonable total cost of ownership for that solution. So let's check this out. First of all, here I'm on Azure portal, I'm showing you the front door, so let me open this backend pool again. As you can see here, I have 2 hosts in my backend pool, but what is more important here is that this pass. This is basically my health probe. As you can see, it will call the API health function, it will use the get method, and it will call it once per 30 seconds. So basically 2 times per minute. Okay, so let's dive a bit more deeper. So this is the dashboard for one of those hosts. This is only for Western European host. So what I can have here, let's check this guy first. So I have the 30 minutes of logs, and the granularity of those logs is 1 minute. This is very important. And first of all, let's check the function execution count. As you can see, granularity was 1 minute, so basically on average we have more or less 300 calls, 300 invocation per minute. This is really important for us. Then the response time. As you can see, on average it was like 21 milliseconds, so let's just keep that in mind. Then 21 or maybe 25 milliseconds on average, that will be the response time for our health probe. The next part is memory working set. So how many RAM we actually consume. As you can see here, on average, that's around like 41, maybe like below 50 megabytes, let's say, on average. So those 3 numbers are extremely important for us. And let me show you why. The next part is the Azure calculator. So here I have my Azure function for West Europe using the consumption plan. So first of all, the memory set. So we agreed that we're using less than 50 megabytes, basically, memory for our health check and or keep alive function. So here the minimal billable amount of megabytes is 128, so we are actually under that limit, which is fine. Next, we agree that the response time is on average like 20-25 milliseconds. Again, the minimal billable amount of response time is 100 milliseconds. So we're actually again under the limit, which is fine. The next part is a bit more trickier. So now we need to understand actually how many invocations we will have per month. And for that, let me use this simple formula. So what I actually have here, as we agreed, as we basically seen actually on those graphs. So first of all, we have 300 invocations per minute. Now we need to multiply it by 60, and we will know how many invocations we will have during an hour. Then we will need to multiply it by 24, so we will understand how many of those we have per day. And then I will multiply it by 30 to understand how many of them I will have per month. So the result is more or less 13 millions. So for now, let's just use 13 millions as a round number. And let's go back here and let's say I will have 13, 1, 2, 3, 1, 2, 3. So 13 millions invocations overall. So this is what I will need to pay for my health check, for my Keep Alive probe, to basically keep that consumption function always up and running. As you can see, the overall monthly cost for that will be less than $2.50, which is actually extremely awesome. The only one trick here is that on each and every Azure subscription, you always have a particular limit of the resources. So basically, the calculator here also considers that limit, so that is why the actual bill will be a bit different. But we can easily emulate that. Let's say that we have not one host, but let's say that we have like 10 hosts in total. So I will just add 1 0 here. So now we have 130 millions invocation. So this is our Azure function basically deployed across 10 different regions in Azure. And here we're talking about $45. So basically 4.5, less than $5 per region to keep that function always up and running with our health probe. So this is really cool. This is really awesome. If you will have a VM, you will be unable to get a VM in Azure basically under that amount of money. You will be unable to get a VM under $5 per month. And also for the VM, that's much more complicated to configure all the auto-scaling rules and stuff like that. So this is really how the economy works. And in addition to that, what I also want to add here is that Azure Functions, they also came with the premium plan, which can scale much faster, but of course it also costs a bit more. What you can do, and what we actually implemented in our project as well, we basically created 2 functions. We analyze the pattern, basically which country uses basically those scans more often during which times, and then we dynamically, which is also available through the Azure Management API, we dynamically change the pricing plan from consumption to premium during, let's say, business hours. So on business hours, we can have even more resources if needed. So this is what you can do in Azure with Azure Functions, and this is how the overall economy for the Azure Functions works. The clock is ticking and we're almost run out of time. So let me briefly guide you through the way how we implemented the zero downtime deployment with Azure Functions. So first, for our production, we were using the front door as a public entry point. Behind that front door, we created 2 different Azure traffic managers and we called them blue and green. And behind each of those, we created basically a bunch of Azure Functions deployed all across the different data centers. So first key takeaway here. So you can chain your front doors and your traffic managers, and that's totally fine. That worked like a charm for us. Second, if you're using the classical approach of hosting your resources where you have like VMs, web apps, or whatever, if you have 2 environments that runs in parallel, you will need to pay for both. In this case, when you're using the Azure Functions, you don't. And the reason for that is, again, you pay only for the actual consumption. So you can easily create a copy of your environment which consists of 10, 20, 30 different servers, and you can deploy to those 30 different servers in parallel, and still you will pay nothing until you will actually switch the traffic from blue to green or back. Another important thing here is, again, because we're talking about the geo-distributed setup, where, as I was saying, you may have like 30 different servers deployed all across the globe. It's really important for you basically to be able to ensure that if you want to roll out a new version, then before you will actually switch the traffic, you need to make sure that all the deployments to all those 30, or how many do you have them in your setup, for all those 30 servers was actually successful. That's really important. If at least one of those failed, you may need to have a manual intervention. You may need to go there, basically check why it was failing, I don't know, do some stuff, or maybe retry the whole deployment again. So with Azure Functions, that's super easy because, again, you may have all those environments up and running. They may be a bit slow, but still they are active, and you will not be charged twice. So I know that my time is over, so if you have any more further questions, feel free to drop me an email. I can speak 3 languages. I can speak Ukrainian, English, and Russian as well, so feel free to use any of those. Drop me an email if you have any questions about this session or Azure in general, or you just want to discuss something about technology. And again, thanks for attending my session and hope to see you soon. Bye.